For this problem, we are going to assume the op amp or operational amplifier is ideal, and then we are going to look at it and find our V naught T. We're given that our VG of T is 38 volts. This is the voltage here. So we're going to write this down like this. And to do this, we are going to do the mesh current analysis, or method I think it's called, where basically we're going to look at all the currents going into this node, which would be our Vn, and this node, which will be our Vp. The N and the P just stands for negative and positive. And we also know that our Vn is equal to our Vp, very important to note. So we are going to have some current flowing into our Vn this way, some because of negative feedback. This is just an op amp rule. If it's set up like this, we're going to have some feedback flowing this way, so some current flowing this way, like this. And then for our Vp, we're going to have some current flowing this way, and then some current flowing this way as well. It's important to note that we have all of these currents kind of flowing into these two nodes right here. Now we're going to start writing this out. We have our Vn over the 80 kilo ohm resistor. So that'll take care of this part right here. We're now going to look at this part. We have a 250, I think, picofarad capacitor, and the equation for impedance, capacitance from impedance, or capacitance to impedance, is Z of C is equal to 1 over j omega c. Now, we aren't given an omega here. And since we aren't given an omega, that means that our Z of C can be equal to infinity. Since it's equal to infinity, we will have a plus Vn minus our V naught, and this is going to be over the capacitor. So we have this node subtracted by this node, and that's just kind of a rule that when we do this we know. And then we are going to have it all over this capacitor, which is infinity. And from this, we know that 1 over infinity, or anything, we'll just say n for anything over infinity, is equal to approximately 0. Any small number over a huge number, basically 0. So this, we're going to zero out. Next, we are going to take care of the voltage going over this resistor. So we are going to have our Vn minus our V naught, and this is divided by the 40 kilo ohms of resistance set equal to 0. And that is our first equation. Now, to keep on solving this, to make it a little bit simpler, what I'm going to do is multiply everything by 80 kilo ohms. That way it cancels out on the bottom. So we are going to have Vn, and then we are going to have a plus. Now, if we cancel this out for this part right here, we are going to have a 2 Vn minus a 2 V naught equal to 0. Rewriting this again, we're just going to have a 3 Vn, and this is equal to 2 V naught. We have two unknowns, so we have to solve for one of them, and we're going to do that with this part down here. We know that our Vp is equal to our V naught. We know that our Vp is equal to our Vn, so we're going to have to plug it in here. But solving for our Vp, we're going to have the Vp minus the Vg, which is 38 volts, and this is being over the 80 kilo ohm resistor. We are then going to have a plus our Vp over our 20 kilo ohm resistor, all set equal to 0. We're going to multiply everything by 80 kilo ohms, and now rewriting this, we are going to have Vp minus 38 volts, and then we are going to have plus, cancel these out, for Vp equal to 0. So adding these together, we are going to get 5 Vp is equal to 38. And so our Vp is equal to 38 divided by 5. And we know that our Vp is equal to our V of n. And so now we're just going to plug this back in. We can see that we'll have a 3 times the 38 divided by 5, and then we can divide both sides by 2, so we'll have a 2, and this is equal to V naught. And we're dividing both sides because we're using this equation right here. And if we do that, we are going to get that our V naught is equal to 11.4. So you would write this down here, and then you would be completely wrong. Because if we look at our op amp, we have this max of 10 volts and this min of negative 10 volts. We can't go above 10 volts, and we can't go below the negative 10 volts. So if we get a value that is above, like this, well, this negative feedback right here is going to be the 1.4. It's going to go back in here, and we're only going to get this 10 volts. I believe that's how it works, but I'm not 100% sure on that. But what I do know for sure is that if we have some value that is greater than the value we have here, our output is just going to be this value. So that means that our answer is 10 volts, and we have solved this problem.